So in our last completing the square examples, we were able to work through things that was something like this. That has a 1 in front as the a coefficient or in front of the x squared. But something has to change in our process if that number switches to something like this. So this second part is taking and completing the square on quadratics that are a little bit more complex. So the first thing we need to do is we are going to factor the number that's in front of the x squared out. No matter what it is, we need a 1 in front of that x squared. So we pull the 2 out. Well, pulling the 2 out of the 8 leaves us with 4x. And we're going to add and subtract a number just like before. We're going to leave this minus 12 at the end. Now the reason I don't have to pull 2 out of minus 12 is because it's not in this parentheses. And so if we were to distribute this 2 through, it doesn't affect the 12. But notice that in the last example, we have to add and subtract the same number so they cancel each other out, right? Well, if I times this 2 through and I've added a number here, it's going to be different than subtracting that same number because it doesn't have the times by 2. So we need to add it to that piece. So they both have to have the number that's out front and what we're adding to the function. So if we take and find our c now, we're going to say c equals 4 divided by 2 squared, which is 2 squared, which is 4. So adding a 4 here and adding a 4 here. Notice that if this 2 comes through, we've added really 8, and we've subtracted really 8 right here. So we still haven't changed the function. This factors to be x plus 2, x plus 2. Right here we have minus 8, minus 12 makes a total of minus 20. Now because the x plus 2's match, we're able to write them in the other form of x plus 2 squared minus 20. I want you to notice something. This number right here is always our b divided by 2. So if we recall our other examples back for a second, b divided by 2 in this first example was negative 3. When we factored it, we got a negative 3 squared. When we did our second one, 10 divided by 2 was 5, and this factored to be x plus 5 squared. Always works out this way. So let's do another example like this. So if we have 3x squared plus 24x minus 16 equals 0, the first thing we need to do is pull a 3 out. Pulling a 3 out of 24 leaves us with 8, and now we're going to add and subtract that same number. Remember that since I have a 3 out here, I have to add a 3 over here. Well, c is now 8 divided by 2 squared, which is 4 squared, which is 16. So I'm going to add a 16 here and add a 16 there into the slots. So the 3 stays out front. This factors to be x plus 4, x plus 4. And out here, this is minus 48 minus 16, which is negative 64. So I get 3x plus 4 squared minus 64 equals 0. There's one more example I want to show you. So, given something like this, we want to find that c that will complete the square. So we're not going to fully complete the square, we just want to find c. And so c is equal to 15 divided by 2 squared. Well, 15 divided by 2 is not really a nice number, right? And so we're going to leave it as a fraction. And when we square a fraction, we'd say 15 squared is 225, and 2 squared is 4. So what we're going to add here is 225 over 4. And if we were completing the square, we'd subtract the same thing on the outside. But what we're trying to show is just what the number you would add. Remember, this now factors to be x plus your b divided by 2 in both slots. Or in other words, x plus 15 halves squared.